Here's a video about 6 basic function families. So these aren't the only functions you'll see, but if you have these 6, you'll see them more than anything else. The first is called the basic linear function or the identity function. So certainly there are other linear functions, but what's the most simple linear function? This one, y equals x. It goes through 0, 0, it goes through 1, 1, 2, 2, and so on. What's the domain? What's the list of possible inputs you could get for x there? Well, the domain is all real numbers. So if you put it in interval notation, it's negative infinity to infinity. What's the range or list of possible outputs? All real numbers. The identity function, of course, has the domain and the range the same. Okay, the quadratic function, the basic quadratic function, or the squaring function, that looks like a parabola. The equation we're looking at here is y equals x squared. If 0 is the input, squaring that gives you 0. If 1 is the input, squaring that gives you 1. If 2 is the input, squaring that gets you 4. If negative 1 is the input, 1. If negative 2, 4, and so on. The domain here, the list of possible inputs, well, you could put in anything you want. Also, you could think about this as the shadow. If you were shining down here, that would be all real numbers, or negative infinity to infinity. The range is not, though. Notice you can't have negative numbers. You could have 0, and you could have anything larger than 0. Okay, the basic cubic or cubing function looks like this. That's y equals x cubed. 0 cubed is 0, 1 cubed is 1, 2 cubed is actually 8. So in the long term, this is growing faster than that. Negative 1 cubed is negative 1. Negative 2 cubed is negative 8. So that's what it looks like. Notice that domain, list of possible inputs, everything. The horizontal shadow of this would be everything. The range would also be everything. If you were shining sideways, notice there's no place that wouldn't be hit. Every possible thing would come as an output. So that's negative infinity to infinity as well. Okay, how about the square root function? The square root function is actually somehow the opposite of the squaring function. It looks like that, y equals the square root of x. For real numbers, we can't take the square root of anything less than 0. So that limits our domain. Our domain is going to be 0 to infinity. You can see that sort of with that shadow, right? The only valid inputs are 0 and things greater than 0. That means the only valid outputs are going to be things from 0 up. So square root of 0 is 0, square root of 1 is 1, the square root of 2 is the square root of 2, 1.4 something rather, the square root of 4 would be 2, and it's sort of the mirror image of this if you just reflected, say this, around that line y equals x. That's what this looks like, and it goes on forever. You eventually can get as high as you want, you just have to go out a long way to do it. Okay, the cube root function, again, it's a mirror of this. It's as if you took this and flipped it around that line y equals x. The equation is y equals the cube root of x. Some people write it as y equals x to the 1/3. Okay? Notice the domain is still everything. And the range is still everything. Here we have points like cube root of 0 is 0, cube root of 1 is 1. You'd have to go up to cube root of 8 to get your next integer output. The cube root of 8 is 2. Okay, how about the absolute value function? Well, the absolute value function, the basic absolute value function, looks like this. We write it y equals the absolute value of x. So absolute value of 0 is 0. The absolute value of 1 is 1. Of 2 is 2. But the absolute value of negative 1 is 1. absolute value of negative 2 is 2. So the domain is everything. Right? You could put any input you wanted to, but you'll only get out numbers that are non-negative. You could get out 0 and things larger than 0. Now, even these 6 can show up in all sorts of varieties. We could translate this up and to the right or left. We could stretch it, but knowing those and being familiar with their shapes is going to help you in all sorts of contexts.